Hi, today I find out an interesting package called C5, which is also a request from one of my viewer, and then I find out this package is very interesting, so today I'm going to talk about this. As you can see, the library is C5.0, but it is actually C5.0. As you can see the command here, it is C5.0. So this is a classification algorithm. So I'm going to bring up my favorite data set, which is the iris data set. And then I'm going to split them into a testing and training data set. So now I'm going to run the model here to using my trained data set and then to predict the species here. So as you can see the summary here. So we have a confusion matrix here, and then this is the decision tree. So we can actually plot this tree here. So you can see that yeah, so this is the decision tree come from this tree-based classification algorithm C5.0. So yeah, as you can see that it seems like these two should be in this. They are the same. Also, they are the same category, but it seems like this variable also play important role to distinguish between this category and then this one. So for some small cases, for some special cases, the petal length can also be an important variable to predict this category here. So that's why, although they're the same, but they are in two different nodes here. So this package allows you to not only allows you to make a classification, but also allows you to give you a better visualization of this decision tree. So now I'm going to make a prediction and then predict on the testing set, and then make a confusion matrix on the testing set. So you can see that there are only two cases that is predicting wrong here. So for this algorithm, there's a parameter called trials. So now if I can specify trial equal 10, and I'm going to make another prediction on the testing set, it seems like there is an improvement. So I think in previously for when I'm working on this, there are some improvement, but it really depends on how do you split your training and testing set. Since I use sample here, so each time is different. So there is an improvement here. So it means like it seems like the model I get from here is already good enough. But yeah, but there's still like two cases here. Two cases misclassified here. So you can always adjust your trials here to make it better, to make your prediction or to make your accuracy better. So in this C5.0 method, there's also another parameter or another option called rules. So if you set rules equal to true, over here you can see that so these are the rules to plot your decision tree. So for example, petal length less or equal than 1.9, and then it is the TOSA. And then this is less than, and here you have greater than 1.9. And then less than petal length less than 5, and then width less than 1.7, and then you have another category. So so if you specify rules equal to true, this will give you detailed rules how the decision tree is made. However, when you are using this rule model, it doesn't allow you to visualize the decision tree anymore, since you have this rule over here. So now I'm going to make another prediction. It seems like there are two cases. So let me update my training and testing set again. So let me see if there's a difference here. Okay, so it seems like there's I think it used to be 1511, so now it's, yeah. So there are two cases misclassified here, and then let me just try trial equal to 10. It seems like this is worse off. So basically, yeah, you just need to try different parameter to improve your model. But if you really want to know how to really improve it, then you really need to understand the math and the algorithm behind this model. So I'm not going to talk about because I haven't really looked into it, but I'm just going to show you this this very fancy algorithm package here. So we talk about the rule model, and then you can also specify in trials in this rule model here. So since this data set is actually pretty small, so the result is not very satisfying in terms of the accuracy or the confusion matrix. So I really recommend you to try something different, or to try a data set that is large enough, and then you can split them 50-50 and to check your model or to check your algorithm to about how you can improve your prediction. So after this C5.0, which is a classification algorithm, I also find out another algorithm that is also pretty interesting. So that is called, how do you say that? Bayes, NaiveBayes method. So I'm still going to use the iris data. So here you just need to call this function here and then specify your y and x. That's it. Did I? Error. So what's going wrong here? Data equal to am I missing a parenthesis here? Okay, so I run this model. So and then I'm going to predict. So now this method, so this algorithm is giving me the probability whether one record or one row, the probability of this record for the category. So you can see that there are totally 3 categories here. So you can see that for the first record, it seems like so the probability for the first record to be under Setosa is almost 100%, or equal to 1. So you can see that for this first I would say about 20 records, they are all classified as Setosa since their probability is very large. And you can see that for the other category, they're actually very small. They are 0 to the -16 or to the -23, so they are very close to 0. So when you specify the type equal to probability, this will give you the probability that this record will fall under which category. And then yeah, you can see that so the higher the probability, the more likely that this record will fall under that category. If you don't specify type equal to probability, then this will give you the actual this will give you the prediction based on that probability. So now I can also make let me try the testing set here, and then P1 equal to test. So so now you can also create a confusion matrix here. So it seems like there are four cases that is misclassified. So so I'm just going to show you these two, which I find it very interesting, or I haven't seen this before. So this 2 package for classification. So if your data set has numeric data, and that the distribution for that for that numeric variable is not normally distributed, then you can edit this category or this option, this parameter here, use kernel equal to true. So this will give you a better result for your prediction when your numeric variables is not normally distributed. So yeah, so here are two methods for classification, and then they are relatively easy to use. All you need to do is to bring in the y and x and then make the prediction and then the confusion matrix. So one parameter in the C5.0 is the trial. You can increase the number of trials to improve your accuracy. And then for the Bayes method, you can use this use kernel when your numeric variable is not normally distributed. So here are two new classification algorithm, which I find it new. So thank you very much. I hope you like it. Thanks for watching, and hope you can like subscribe my channel or recommend my channel to your friends. Thank you so much.